Here, guys. JC. Go ahead and look up here. Now, over here. This is a property that we learned in the very, very beginning of the school year, where if I'm multiplying, I can literally just change the order of things and not change it, and not change what I have here. So when you have something like this, what I want you to do basically is just literally move the constants, the numbers to the very, very front, and then rewrite what you have. Here I still have n to the power of 9, and I still have n to the power of -1. Now you see what property I can apply here. What is it? Addition. One of them is negative, so it's going to be 9 minus 1. What does that give me? 8. So I have 2, n to the power of, which you just said, which was 8. Simple enough? So in these problems, when I have a constant, we can just move it to the front and not change anything about that one. In this one, again, review from the hardest stuff from last week. If I wanted to find the square root of 4, what would you tell me there? What is the square root of 4? 2. 2? But what do I still have?
Power of 3.
The power of 3. And what is that one?
8.
8. 2 times 2 times 2, which gives us simply 8. Simple enough?
Yeah.
Yes? Is there any questions about this?
No.
All right, let's go ahead and move on now. Alrighty, go ahead and have out your notes for the day. Here, we're going to be talking about polynomials. Polynomials. This is something very new to us, and we're going to start with monomials. That word mono in the front means one. Here's the definition. A monomial can be simply a number. While I'm doing this, I'm also going to give us an example. So it could be a number. Griselda, give me an example of a number. 4. That can be a monomial. Another thing it can be is a variable. It can also be a variable. Remember, you are writing this down. You already give me an example of a variable. X, we can use X. Finally, it can also be a combination of both. That means I have a number and a variable. Sam, give me an example of a combination of both of these. A number with a variable. Something else that we have not used. Give me your own number, your own variable. Don't overthink it. Simple.
55.
What is it?
55 to the power of 3.
55, just give me a variable now. V, 55V. That's another example. It could be a number, a variable, or a combination of both. A number and a variable. Do you see that? That's a monomial. We've learned this before, but we've learned it as a term. This could be a term, this could be a term, or this could be a term. Now we're giving it a specific name, a monomial. The degree of the monomial is the following thing. Write this down. It is the sum of the exponents of the variables. The sum of the exponents of the variables. That sounds kind of tricky, so I'm going to give you an example down here. If I have the following monomial, let's say x to the power of 3 and y to the power of 4, well, if I want to find the degree of the monomial, it tells me there is the sum of the exponents on the variables. Notice here I have 3 and 4. It's the sum of the exponents, which is what? 3 plus 4 gives us 7. So there the degree would simply be 7. Oftentimes, on a monomial, you may only have one variable. There, if I were to find the sum of the exponents, well, since I only have one variable, what is the sum of the exponent on this one? It's just 2. So there, the degree is going to be simply 2. On the next one, I'm interested. I have x and y as my two variables. If I want to find the sum of the exponents, I need to find what the exponent on the x is also. What is it?
1.
1. If I have nothing there, I'm going to assume it's simply 1. So what is the sum of those exponents?
4.
Yeah, 3 plus 1 is 4. 1 plus 3 is 4. Alright. Do you see the pattern there? Simple? Oscar, this next one. Go ahead and give me the answer there.
6.
Yeah, 6. 3 plus 3, 6. Eileen, attempt the last one there, at the very top. What would you think there? 0. Great job. So here, whenever you don't have a variable, that means I don't have an exponent on the variable. There's nothing there. We're going to say it's simply 0. Good job, Arlene. JC, you have a question? You want to help me out? Why is it not 1? JC asked a really good question, class. Here, the definition tells me that the degree is the sum of the exponents of the variable. Do we have a variable here? No, therefore I have no exponent. We're going to say 0. That's why it's not 1. The next one, Jasmine, what is the sum of the exponents there?
4.
Yeah, I only have one variable. The exponent on that one is 4. Good job. Jocelyn, help me out. This one over here. 5. Easy. Now this one. Estefania, help me out with this one. What is the degree of that monomial? 1. JC, how did I get 1 there?
Because there's an invisible mark.
I have a variable. The invisible exponent I have there is 1. So my answer, 1. Again, the last one, Melanie. If I only have a number, no variable, what do we say there as the exponent, as the degree? 0. Good job. Easy enough, class? Yes? Good. That's the simplest type of polynomial that we're going to learn about. Moving on. I want you to write the following definition down under polynomial, and then I'll sort of explain it as we go along. The definition is, a polynomial is the sum of monomials. That's all it is. Each little part, each part is called a term. Each part is called a term. And this is sort of what we learned in the previous units. Here, these are all monomials, and they're all considered a single term. Off to the side, we're going to go ahead and write the following notes so that you sort of get in the mind of knowing what these things are actually called. So today we're dealing with polynomials. Within this category, there are 3 other things that fall within this category. The first type we learned already. It is a monomial. A monomial only has one term. One term, which is what we looked at just now. Something that has variables or numbers, but that is just one term. The second type is called a binomial. Think bicycle. How many wheels does a bicycle have? Binomial simply means that we have 2 terms. 2 terms. The last type is a trinomial. Do you see the pattern?
Yes.
How many terms does this one have?
3.
Trinomial, tres, think 3 terms.
Triangle.
3 terms. Easy enough? So here, these are sort of the subcategories of polynomials, and I'm going to sort of explain how you can tell what type of polynomial you have. So once you're done, go ahead and look up here, so I know you're ready to move on. Alright, so in the example that we're given, go ahead and look up here now. You may start writing. At the very top, we learned what a monomial was. This means that we have one term here. One term, that's what it would look like. A number, a variable. If I have 2 terms, what is that one called? Binomial, again, it's separated by a sum, or sometimes also subtraction. But here, how many terms do I have? 2. This is called a binomial. What if I had 3 terms? Trinomial, simple. I have 1, 2, and 3 terms separated by addition or subtraction. If I have 4 or more, the name for that is simply a polynomial. Polynomial.
Has 5.
Again, anything other than 4, 4 or more is going to simply be called a polynomial. There's only a name for the first 3. 1 term, 2 term, and 3 term. So let's go ahead and do this exercise here. First thing on this problem, one thing you should know is the standard form of a polynomial. In my other classes, a lot of students were sort of confusing this, so I need you to pay attention here. There's a specific order that you write polynomials. That is called our standard form. And the way it goes is you have the biggest exponent on the far left. So in this example, we started with the biggest exponent over here of 3, and then you just go down till you get to the smallest thing. So here, we went from x to the power of 3 to x to the power of 2, x to the power of 1, and our constant is at the very end. Let's take the following notes. The degree, I know it's a lot of information just in 1 second, but you'll be able to see this more when we do the examples. The degree of a polynomial compared to a monomial is simply the biggest exponent. Let's go ahead and write that. The degree of the polynomial, we're going to say it's the greatest exponent you have there. Exponent. Looking at this polynomial, what is the biggest exponent I have there? 3. And that's simply what the degree is. The number that's in the very first term, that is called the leading coefficient. So those are just some extra notes to add there. So again, what you have to know mostly is the leading coefficient there, the degree of the polynomial, that is simply the biggest exponent. In this case, you are no longer adding the exponents together, it is only the biggest exponent. That's when you have 2 or more terms. Alright, here we have some examples to go through before, and then you're going to get some practice. So here, starting at the very first one, standard form. How many terms do I have here? 1. So right off the bat, I can label the type of polynomial. What is it if I have 1 term? Monomial. Let's write that down in the blank. Over here, this is called a monomial. Let's write this down. Monomial. And when I have monomials, guys, when I have monomials, what do we do to find the degree? If you look at the very top, what do we do to the exponents? Added them. So if I add my exponents, what do I have? Simply 4. Good. And standard form, since I only have 1 term, I can't rewrite it any other way. Just write it as it is. Write it as it is. I can't change the form of the polynomial. It is just 1 term. I'm just going to rewrite it exactly as it is, because I only have 1 term. It's a monomial. The next one. Lucero. On this next one, how many terms do I have here? Total, separated by addition or subtraction? Can you, 3 terms. If it has 3 terms, what do we classify it as? Trinomial. Let's write that down there. It's a trinomial. We have 3 different terms. Trinomial. And just like I mentioned, anything other than a monomial, the degree is simply the greatest exponent. Looking at this problem, what is the greatest exponent? Miguel, you have it. What is it? 2. That's my degree. Simple enough. And again, one of the most important things is putting it into standard form. That means that I'm going to put the exponents from greatest to least. So here again, my greatest exponent is 2. I'm going to put that term in the very front and keep it as it is. Here, this term is positive. I'm going to keep it positive. So plus positive 5x squared is going to be the first thing. So we're going to say 5x squared. Since there's 3 terms, I'm just going to put them in standard form in order. 5x squared, next thing is just the variable by itself, minus x. X is negative, we're going to keep it as it is. And the last thing we have on this problem is the 4. 4 is positive, we're going to leave it positive. So all you're doing here is simply just changing the order to put it into standard form. Starting with the greatest exponent, all the way to the least one. Our numbers always go at the very end. Our constants go at the very end. Easy stuff? Let's do this last one quickly so we can move on. How many terms here, Sam? 2? What type of polynomial is it? If I have 2 terms. If I have 2 terms. Read it again. 2 terms means it's a binomial. Binomial. And this one, what is the greatest exponent I have?
5.
5, that's my degree. When I rewrite it, Yori, help me out. We're going to put the greatest exponent at the very front. So q to the power of 5. We're going to start with that term. What's next? And just the next term, the first term. You have it. Yep, just like that, Yori. Good job. That's all we're doing. We're just changing the order. I'm going to leave my notes up here. Now on the next page, you have a little chart to fill out. You're going to do this with a partner. I'm going to give you 4 minutes. Where's my timer? Yori, 4 minutes on the clock. You got a timer? Take it out. 4 minutes on the clock, guys. You're working with a partner to fill this out. Go ahead and begin. Start it.
Would that be 6?
Over here?
Yeah, because it's like a...
Yes. Quick thing here. You want to explain it?
Yes.
Go for it.
So, that one's a binomial.
It's
Binomial.
But he's asking specifically though, why
So
is the
then-
degree here not 6?
It's not 6 because you're not supposed to add, because it's not a binomial.
Only for monomials, when you have one term, you add the exponents here, we use the greatest exponent. In this case, it's 5. Yeah? Alright, go ahead and resume. Got cheese up now? Got cheese up? Yeah? Alright, Mavs.
Yes.
Mavs.
Yeah.
Alright guys, this next part, here, let's go ahead. You still have about 3 minutes and 30 seconds. We're going to go ahead and change this to independent practice. You're going to do this by yourself. You still have 3 minutes and 30 seconds. Go ahead and begin. 3 minutes. Eventually, yes. when I have two or more terms, the greatest exponent, the biggest exponent is our degree. So in this case, I have two terms, right? The greatest one. This one again, we're not having it. What is it?
Amy.
You already how much time we have left? You don't have camera anymore?
Oh, so am I.
Nothing doing there? I have time to check it right now. Good trinomial. Over here, when I have two or more terms separated by addition or subtraction, the degree is simply the biggest exponent. What's the biggest exponent I have over here? Just one? What about over here? The biggest exponent. 3. That's my degree. It's the biggest exponent. Alright, Mavs.
Yes.
Let's come back as a class. We're going to go over these. I'm just going to call on you so that we can move on. Starting with the very, very top on this page. Here, Melissa, go ahead and give me this first problem in standard form. If you don't have this down, guys, you should be writing it in your notes while we hear from Eliza. Standard form. Plus 4, good job. There? Yeah, what's the degree there? Yeah, the only exponent I have there is 1. That's the biggest exponent, it's 1. And what type of polynomial do I have there? Binomial. I only have 2 terms. That one's called a binomial. Binomial. Arturo, give me the next one in standard form.
Negative t to the power of 3 plus t to the power of 2 minus t to the power of
Minus 10t. Good. Here, guys. On this one. Wait. I need to go over something. On this problem, whenever you write something in standard form, listen, all that you're doing is simply changing the order of the polynomial, putting the biggest exponent first, and you're increasing to the smallest one. So notice how we go from 3, 2 to just 1, you change the order. Here, the degree is the biggest exponent. Oscar, what's my degree here? What's the biggest exponent I have? 3, that's it. Simple. And then Amy, how many terms do I have there? How many different terms do I have? 3, so what is it called? Trinomial. Simple enough. Trinomial. Again, Christian, here, we're no longer adding the exponents. When I have more than 1 term, I use the biggest exponent as my degree. The biggest exponent there is 3. That's what I use. Let's fix it. Alright, the last one. Griselda, give me this in standard form.
X3 plus 2 is 2.8.
Well done. Just like that. Mariano, what's my degree there of the last one? What's the greatest exponent? 3. That's all he's asking. The greatest exponent is 3. And how many do I have there? How many terms?
2.
What is that one called? Binomial. Simple enough? Good. It's called a binomial. Awesome. Awesome. All right. Now, today's lesson is very simple. We're just going to be adding and subtracting polynomials. That's all we're doing, adding and subtracting, starting with the easiest one, which is addition. Go ahead and write down the 3 steps to simplifying polynomials. First thing, we're going to say we want to remove parentheses by distributing. By distributing. Remove parentheses, and you do so by distributing. The next thing we want to do, JC, write these notes down. You want to identify like terms. Like terms. I'm going to write a little note to the side. Like terms means that you have the same variable, and you're going to learn today that like terms also have the same variable and same exponent. The exponent that they have matters when combining like terms. You must have the same variable and the same exponent. Finally, when you identify like terms, you combine those like terms. Combine like terms. Combine like terms. That's all you're doing at the end. You just combine those like terms. Alrighty. When you're done, go ahead and also look back up here so we can go to the examples so that you learn how to add polynomials. Alrighty. So first thing again, when I see a problem like this, I have to first thing and notice the operation there. What we're doing is adding the polynomials. And we're going to follow the same steps with that problem there. First thing, I want to remove my parentheses by distributing. Here though, if I have parentheses here, what invisible number do I have here that we don't write? 1. And here, you're distributing an invisible 1, and Kevin, I heard you. It's the same thing, right? If I multiply anything by 1, I get that exact same thing. So with addition, the quick and simple trick there, notice that you're adding and just rewrite everything you have there without parentheses. Because you distributing that 1 won't really change anything there. So we're going to do, distribute the 1 and just write this exactly as it appears without parentheses. So I have 6x plus 15. Notice here we will distribute, but that 1 won't change anything. So we can just rewrite this without parentheses. A positive 8x and negative 3. Let me go over this first, and you can go. Alright, now, here, next step is to identify like terms. If you have a separate color pencil, what I would do is take it out so that we can go ahead and determine the like terms. I'm going to use those that have an X, put a circle around those, and put a square around those that are just constants. Those that have constants. That way I can tell apart the different terms. Now we just combine them. What is 6x plus 8x? 14x. What about that 15 minus 3 when I combine those two? That gives me positive 12. And that there is simply my answer. I can no longer simplify that even further. And that's going to be my answer there. Did we see how we got that? Yeah. Yes? I'll move it up. Don't worry. I'll move it up. That's all that we're doing. Combining like terms, adding polynomials. The next one, let's do one more example. What is the invisible number that I have out here next to the plus? 1 again, that's the one that I'm distributing. But just like I told you, we're adding. Therefore, all this is just going to stay the same. I can rewrite this whole thing without parentheses. Let's go ahead and do that. 3x squared plus x minus 6 plus x squared plus 10. Plus 10. And this example is better for the second step over here. Because like it says up here, we have to have the same variable and the same exponent to combine like terms. So here, we now have an x to the power of 2 and also just an x. Here are the like terms on this problem. Those that have an x squared are like. Those that just have an x is its own term, and I'm going to combine that with the other thing that also has an x. The final thing I have there are constants, just numbers, and I combine all of those together. So now let's just combine these circles over here. X squared. 3x squared plus x squared gives me, I'm just adding those numbers, 3 plus 1, 4x squared. That's the first term. I have 4x squared. Next thing, I want to combine my x's. X plus 4x gives me class 5x. Finally, negative 6 plus 10, or 10 minus 6. What does that give me? 4. And this here is fully simplified. I can't do anything else. That is going to be my final answer. My final answer. Do we see how we got that? Again, main thing here, like terms must have the same variable, and Miguel, same exponent. Same exponent for you to be able to add them together. Any other questions on this part?
No.
Arturo?
So if it has an exponent, it has to be separate.
If it has an exponent, it has to be separate. Can you explain that? What do you mean? Oh, yeah. Exponent, it's its own thing. It combines with something that has the same exponent variable. Ashley?
So you don't combine the exponents?
We did that over here. We did combine those.
But that.
But the exponents themselves, we don't combine them. It stays the same way as that. Whenever we combine these to like terms, we don't add the x's just stays there. That's just like the variable. And these two are different now because one of them has an exponent. Don't add the exponents, just add the coefficient. Alright. Now on the next page, you have 2 practice problems. You're going to work on these independently. I'm going to give you a total of 3 minutes. I'm going to leave my notes up here, but you're working on these 2. Here are the steps. Follow these steps. If you are stuck, you already 3 minutes on the clock. You're working on this independently. Go ahead and begin.